Hello, what's your name?
I'm Bartholomew Hamish Montgomery, but you can call me Barty. I study physics and philosophy.
What have you been studying?
Scientists have no idea why the Earth isn't completely covered in snow and ice. So stars like the sun, we know, get brighter and hotter throughout their lifespan. So
Do we know that or do we think that?
we have very good reason to think that. Of course, we
Okay.
can't observe the same star over very long, but if we look at stars of different ages, the older ones are hotter and the younger ones are cooler. So this gives us good reason to think that the sun will be hotter in a million years' time than it is now, and that a few million years back, more accurately a few billion years back, the sun was notably cooler than it is now. And if it were notably cooler, then we might have expected the Earth to be covered in snow and ice, like it was partially in the last ice age, but even then, the snow and ice didn't get as far as the equator.
When we had the Ice Age, the snow wasn't at the equator.
No, so the glaciers only got about as far south as sort of England, sort of halfway down the United States. They didn't get all the way to the equator. One of the reasons why we think the Earth must have been cooler is because the sun was cooler a few billion years ago.
Sure.
And this meant there would have been snow and ice around the equator, and there's sort of geological evidence to suggest that there was. But what's difficult about this is that we don't know how that snow and ice would have ever melted. And that's because of something called the albedo of the planet. And the albedo of the planet means how reflective it is. So snow and ice, because they're white and reflective and shiny, they reflect a lot of the sun's energy straight back into space. And it doesn't end up warming up the Earth because it all just gets reflected straight back. And so when you have a planet that's completely covered in snow and ice, it's actually very difficult for it to heat up because no matter how much energy the sun is chucking at it, it just reflects it all straight back into space. And so once the planet is already covered in snow and ice, it's very hard to melt it because even as the sun gets more intense, like it is now, it's slightly warmer. If that energy is just getting reflected back into space, it's not warming up the Earth, and the snow and ice wouldn't melt.
So it's like the Earth is wearing a white t-shirt that's keeping it cool on a sunny day.
Exactly.
Right.
And that means, and even as the sun gets brighter, the Earth wants to stay cool because their sort of white snow t-shirt is reflecting it all back. This sort of relates to some of the stuff we're worried about with climate change, because as much as we don't have snow and ice everywhere on the Earth now, we do have it at the North Pole and at the South Pole, and we know that those ice sheets on the whole are melting faster than they're growing back again. As the ice and snow melts at the North Pole and the South Pole, this means that the Earth becomes less reflective to sunlight, and so it will warm even faster. And so this means that even if, say in 100 years' time, if lots of the ice and snow had melted, even if we could get carbon dioxide levels back down to where they are now, the planet would still be hotter because it wouldn't be as good at reflecting sunlight back out, and it would be absorbing more of it.
And speaking, on a completely related but not at all privileged note, did you know that every decade the snow coverage in the Alps reduces by 10%?
By 10%?
And that's been the case since the 70s.
That's ridiculous.
We're not going to be able to go skiing anymore.
What about my ski season?
Literally. What about the skiing? Think of the skiers.
My Oxford term doesn't finish till March. When am I supposed to go?
So we just don't know why it isn't covered in snow.
Well,
what about like the asteroids?
So asteroids is one explanation. It could have been that asteroids brought in lots of greenhouse gases like carbon dioxide and methane, the sorts that we seem to be pumping out a lot of these days. The most prominent idea for how the Earth successfully heated up was that volcanoes released a lot of carbon dioxide and methane and other greenhouse gases, sulfur dioxide for instance, into the atmosphere, and that this enabled the Earth to warm up.
But if the world was really cold, then why were there volcanoes?
Well, volcanoes come from the sort of internal heat of the Earth, so you have lots of radioactive materials in the middle of the Earth which cause it to warm up. That's what sort of powers the volcanoes, but that's different from the heat coming in from the sun, so that was weaker, but the internal heat of the Earth was still very strong.
Okay, thank you very much.